Right, we're going to take a look at library of functions, piecewise functions. Um, so the square root function, when in doubt, the nice thing in this course is with these basic parent functions, if you're not sure what it looks like, just do an XY table, throw in a few points. You know, if I take the square root of -2, I'm like, oh, I can't do that, right? That doesn't work. Can't take a square root of -1, not in the real numbers at least. Now let's throw in 0. Well, the square root of 0 is 0. Let's throw in 1. The square root of 1 is 1. I throw in square root of 2, but I don't know what the square root of 2 is, so I jump to 4. I know the square root of 4 is 2. I could throw square root of 9 in, right, and 3, and so on. I get these points, right? 0, 0, 1, 1, 4, 2, and so on. Anyways, you start drawing your square root curve, and you notice your domain is from 0, including 0 on and to the right, right? The range here is from this 0 and up. So 0 is the lowest y value and up. It is increasing on its entire domain. Of course, you do increasing, decreasing with open intervals. That's why the 0 has a parenthesis on it, because we do open intervals for increasing and decreasing and so on, right? And we do similar things with the square root function, right? So with the square root, we could say, let me throw in a few points. I take the absolute value of -3, which is 3. I take the absolute value of -2 to get 2. I have to take the absolute value of -1 and so on. And I plot these points, -3, 3, -2, 2, -1, 0, and so on, right? And you'll see that V shape for the absolute value, which, there's all this other stuff here, has a domain from, notice it goes in both directions here. All x values are defined, so your domain's negative infinity, positive infinity. Your range goes from 0, it includes that 0 and up, right? So range would be lowest y value and up. It's increasing on this side, right? So from 0 on, and then it's decreasing on this side from negative infinity up to 0, right? The identity function, that's just y equals x, right? So we've got the line y equals x. Again, the domain, all real numbers, negative infinity, positive infinity, range low to high, all real numbers. It's increasing on its entire domain, right? It's going up and to the right, and it's decreasing nowhere. Keep going with our square function, square y equals x squared. Again, you're just throwing in values. You know, y equals x squared. Throw the x in and square it. You get, -2 gives you the 4 right there. Throw in -1 and square it. -1 squared is a 1. 0 squared 0. 1 squared 1, and so on. And you see that parabola, right? There's our square, which has a domain of all real numbers. The range, though, from 0 up, it's increasing over here, and it's decreasing over there on the left, right? So that's our parabola, y equals x squared. This one also, I'll make a note on this as well. This y equals x squared, this is symmetric about the y-axis, which means it's an even function. It's an even function. In other words, f of -x equals f of x, right? So don't forget that about y equals x squared. Well, let's go to x cubed. I throw some points in here, like -2 cubed, -2 times -2 times -2 is -8, -1 cubed is -1, 0 cubed 0, and so on. And you get these points, you know, -2, -8's down here, -1, -1, 0, 0, 1, 1, 2, 8, and so on. You draw that thing. Whoops, I didn't draw that very well. Try that again. Kind of follow my graph there. The domain's all real numbers. The range is all real numbers, low to high. It's increasing throughout its domain. It's not decreasing at all. And the last thing you should remember with this one is this is symmetric about the origin. In other words, it's an odd function. Don't forget, this is the classic odd function. In other words, f of negative x equals negative f of x. Okay. Cube root function. Let's say we took some cube roots, like the cube root of negative 8 would give us, negative 8's negative 2, negative 2, negative 2. I'm looking for 3 of a kind. So that's negative 2. Cube root of negative 8's negative 2. Cube root of negative 1's negative 1. 0, 0. 1, 1. Cube root of 8 is 2, and so on. You start graphing those points, and you get this cube root function, which is all reals, has a range that's all reals. It's increasing throughout. It's going up and to the right the whole time. It's not decreasing at all. This one also, by the way, is symmetric about the origin as well. It's an odd function, just like y equals x cubed. And that leads us to, that'll kind of help us out with piecewise defined functions. So piecewise defined functions are simply functions made up of two or more functions. For example, here's the first one. F of x equals x plus 2 if x is less than negative 3, and f of x equals x minus 2 if x is greater than or equal to negative 3. Let's start out with just finding some functional values. F of negative 4. Well, I'm plugging in negative 4 for x, right? F of x, f of negative 4. Plugging negative 4 in for x. The question then is negative 4 less than negative 3? Or is negative 4 greater than or equal to negative 3? In other words, am I going to plug it into the top function or the bottom function? Which one is it? Is it negative 4 less than negative 3, or is negative 4 greater than or equal? Yeah, f of negative 4 is less than negative 3, so I'm going to plug it into this one. So I'm using, let me write that, since negative 4 is less than negative 3, use the top. So f of x equals x plus 2, f of negative 4 equals negative 4 plus 2, f of negative 4 is negative 2. All right. In other words, the graph would have that point, negative 4, negative 2 on it for sure. Let's look at the next one now. Is negative 4, is negative 3. Is negative 3 less than negative 3? No, that's false. Is negative 3 greater than or equal to negative 3? Yes, it is. So I got to use this bottom one. Negative 3 is greater than or equal to negative 3. Use the bottom one. So f of x equals x minus 2. F of negative 3 equals negative 3 minus 2, or negative 5. So f of negative 3 is negative 5. So it would have the point negative 3. Negative 5 would be on the graph, right? All right, let's do one more value here, and then I'll kind of walk you through how to make this happen with the graph here. F of negative 3 halves. F of negative 3 halves. Well, negative 3 halves is greater than or equal to negative 3. So I'm going to use the bottom one. Negative 3 halves is greater than or equal to negative 3. So I use the bottom. Again, so f of x equals x minus 2. F of negative 3 halves is negative 3 halves minus 2. Well, that's negative 3 halves minus 4 over 2, or negative 7 over 2. The answer to that one. All right, now let's go ahead and let's actually graph these things. So what I'm going to do when I'm graphing it is I'm going to first take a table of values with this top one, okay? So for f of x equals x plus 2, notice my x values have to be less than negative 3. I'm going to put negative 3 on there, but I'm less than that. So I'm going to say it's open. It goes right up to it, but as it does not include negative 3. Now I got to pick x values that are less than negative 3. Well, less than negative 3 would be those values, right? I got to go to the left of that x value of negative 3. I just cannot include negative 3. Remember, negative 3 is not less than negative 3, but put the point on as an open hole because it'll go right up to it. Now plug those points in, even including the negative 3, because again, oops, that's a plus 2 there. We're not including that. So the first point I'd put on there is I would have negative 3, negative 1. I make that open. Okay. And now I plug the negative 4 in. Again, I'm plugging it in. I'm not including that negative 3 point, but I am including the other ones that are less than negative 3. So let me plug in negative 4 plus 2. That gives us negative 2. So I got negative 4, negative 2. There's negative 4, negative 2. Plug in negative 5. Negative 5 plus 2 is negative 3. Negative 6 plus 2 is negative 4, and so on, right? This keeps going. And so you plug negative 5, negative 3, negative 6, negative 4. And you can see that this will just keep going. That's that part, the top part of this piecewise defined function. Now let me do the other one. I'll do it in red here. Let me do the bottom one now. So let me do, now I'm going to do f of x equals x minus 2. I'm going to do this line, but only when x is greater than or equal to negative 3. So when I do this table of values, I'm picking negative 3, but this will be closed because I can include it, or equal to, and then I'm picking x values bigger than, greater than negative 3. Well, greater than is to the right of negative 3. So pick those values, plug them in one by one, x minus 2. So f of x equals negative 3 minus 2. That's negative 5. There's the first one, negative 3, negative 5. And it's filled in. It's closed. Now I plug in the next one, negative 2. Negative 2 minus 2. Well, that's negative 4. Negative 2, negative 4. Plug in negative 1 minus 2. That's negative 3. Plug in 0. 0 minus 2 is negative 2. Anyways, we keep going with this. 1 minus 2 is negative 1. 2 minus 2 is 0, and so on. And you'll see this is that line, right? Remember, this is a line, mx plus b. It's a line, but it's only part of the line. It's only the part of the line from negative 3 on is the only part of this line that you have, right? So that's the equation, or I'm sorry, that's the graph of that piecewise defined function. All right, when you're taking a look at f of negative 1, you got to decide, is negative 1 less than 1 or is negative 1 greater than or equal to 1? Well, of course, it's less than 1, so I got to use the top one. So you plug in the negative 1, so I got negative 1 half times negative 1 squared. So f of negative 1 is negative a half. Negative 1 squared is just a 1, so you just end up with negative a half. So you have the point negative 1, negative a half on the graph. Let's do the next one here. Next one, f of 1. Is 1 less than 1? No, it's not. 1 is greater than or equal to 1, so I'm going to use the bottom one. F of x equals 2x plus 1. F of 1 would be 2 times 1 plus 1, so f of 1 would be 3. And then this last one here, square root of 9/10. Square root of 0, 0. Square root of 1 is 1. Robert was very good about recognizing square root of 9/10. Well, that's less than 10/10. 10/10 is 1. So we're taking a square root of a number less than 1. So it'll be less than 1. So we're going to use this top one. Square root of 9/10 is less than 1. So f of x equals negative 1/2 x squared. Plug in square root of 9/10. So we got negative 1/2 times square root of 9/10 squared. Well, if I square a square root, I undo it. Square root of 9/10 times square root of 9/10 is just 9/10. So we end up with f of square root of 9/10 ends up being negative 9/20. All right, now let's do some graphing of this thing. Can I erase all this? Now when we graph, let's go ahead and graph the top one. So I'm going to pick value f of x. This is the one I'm going to graph, negative 1/2 x squared with x values less than 1. So I'm going to start at 1, but I'm going to make it open because I got to be less than 1. So less than 1, less than 1. And I'm going to plug those in one by one. Now this is a squared function. So think of the parabola. It's going to look kind of like the parabola, except it's only going to be part of it. And I don't know where it's going to be, but we'll find those points. Let's plug in the first point. Plug in 1. Well, 1 squared is 1, so I just end up with negative 1/2. So I got 1 negative 1/2, but that's open. So 1 comma negative 1/2, that's open right there. Well, let's plug 0 in. Well, negative 1/2 times 0 squared. 0 squared is 0. 0 times anything is 0. So I got 0, 0, and I fill that in. That's filled in. Now I plug in negative 1. So I got negative 1/2 times negative 1. Well, negative 1 squared is a positive 1. So I got negative 1/2. So negative 1, negative 1/2, but it's filled in. Plug in negative 2. Well, negative 2 squared is 4, so I got negative 1/2 times 4. So I got negative 4/2 or negative 2. So I got negative 2, negative 2 right there. I could plug in 3, but I'm going to plug in negative 4 is my next one. Whoops, negative 4. Negative 4 squared is 16. Negative 1/2 times 16 is negative 8. So that'd be kind of a good one. 1, 2, 3, 4, 6, 7, 8 right here. Anyways, I could keep going with values, but I can kind of see my quadratic there. That's that part of the piecewise defined function. Now, let's do the other one. Let me do the other one. Let me do it in black. Let me erase some of this. I have a little room here. Now I'm picking, so here's the function, 2x plus 1. So this is a line. This is a line. I'm going to pick x values greater than or equal to 1. I'm including a 1. Greater than or equal to. Pick numbers greater than or equal to. Again, 1 is included on this one. So f of x equals 2x plus 1. Throw the 1 in. 2 times 1 plus 1. I got 3. So 1, 3 is closed. 1 comma 3 is closed. I'll plug in 2. So I got f of 2 would be 2 times 2 plus 1. I got 4 plus 1, 5. 2, 5. 2, 5, and I could keep going with this, right? 3 would spit out 7, 4 spit out 9, and there's that line. And you notice f of x equals 2x plus 1. It should have a slope of 2, right? Is it going up to right 1? Yes, it is. Up to right 1? Yes, it is, right? So those will be on the, or it'll be showing that, but there's our piecewise defined graph there with a part of a quadratic and part of a line shown. This piecewise defined function, we've got 3 now. F of x equals 0. Here's the first one. F of x equals 0. Well, if you think about what does y equals 0 look like? Y equals a constant. That's just y equals 0, right? That's just the x-axis. It's the horizontal line, y equals 0. But it's only part of that line. In other words, the part where I'm less than negative 3. So I'm not including negative 3, but I got to be less than it. So f of x equals 0. F of x equals 0. Plug in negative 3, and I get 0. Right? There's nothing to plug into. Plug in negative 4, I still get 0. Still get 0. Still get 0. Make sure the negative 3, 0 is open on this when you graph it. Negative 3, 0. Negative 4, 0. Negative 5, 0. Negative 6, 0. So this is just that part. Whoops, I didn't draw that very good. Straight out to the left. It's that part of the line y equals 0. So not including -3, 0, right? Everything to the left of that. Okay, that's the first one. Let's do the second one. F of x equals -x. But only when I'm less than 0, so open here, and greater than or equal to -3. Well, if I'm less than 0, but greater than or equal to -3. So I got to be closed. I got to be including -3. And it's y equals -x is this one. So it's that part, but we're only going to have part of that line. So f of x equals -x. I'm going to be open. When I plug 0 in, so I get 0, 0. F of x equals -x. Let me throw in -1, -1, which is a positive 1. Throw in -2, -2. Throw in -3, -3. I get 3. So 0, 0, -1, 1. Let's go throw those in. 0, 0. Oh, was it open or closed? I can't remember. Open there, and then closed at -3, 3. And then closed here, and I had -1, 1, had -2, 2 as well. So it's only this part. It's a line segment. It's only that part of y equals -x. Okay, let's do the third one. The last one, let me do this in black. Erase this real quick. Let's still some room. So f of x equals x squared minus 1 when x is greater than or equal to 0, greater than or equal to. So I'm going to be closed. I'm going to be including the 0, but then I'm picking greater than or equal to as many as I want. F of x equals x squared minus 1. Throw the 0 in. 0 squared minus 1. 0 minus 1 is -1. Close that. 0, -1 is closed. Closed right there. Throw in these other ones. 1, f of 1 would be 1 squared minus 1. Well, 1 minus 1 is 0. Throw in 2, f of 2 is 2 squared minus 1. Well, 4 minus 1 is 3. 3 squared minus 1, 9 minus 1 is 8. So 1, 0, 2, 3, 4, 8. And think about this. What is this looking like? This is looking like a quadratic. It's like this one, but it's actually that -1 will drop it down. So that's why it's down here, down 1. We'll talk about transformations later. So that's kind of the look of this graph. And I should have plugged in those points at the beginning. I forgot to. So let's go ahead and plug these in. F of 0. Well, 0 is greater than or equal to 0, so I'm plugging it into the bottom one. -1. F of -1. Well, -1 is less than 0, but greater than or equal to -3. So I'm plugging it into this one. So I got -1 or +1. F of the square root of 10 over 2. Well, square root of 10 over 2, let's think about 0 is the square root of 0, 1 is the square root of 1, 2 is the square root of 4, 3 is the square root of 9, square root of 16 is 4. So this, just the top part, square root of 10, square root of 10 is about right there, 3 point something. So we got 3 point something divided by 2. So this is about, I don't know, 1.58, 1.57, I don't know, somewhere in there when I divide it by 2. So this is what I'm looking at, 1.58. And you could just punch that in, right? Square root of 10 divided by 2, see what it is, and get that 1.58. So that's the one well, 1.58 is greater than or equal to 0, so I got to use the bottom one, x squared minus 1. F of x equals x squared minus 1. Plug in the square root of 10 divided by 2. So I get the square root of 10 over 2 squared minus 1. So in other words, I have square root of 10 squared is 10. 2 squared is 4. So I have 5 halves minus 1. 1 is 2 over 2. So I get 3 over 2 is what I end up getting for square root of 10 over 2. And finally, let's do negative square root 11. Well, if you punch that in, you'll get, negative square root of 11. Well, square root of 11 is 3 point something. So this is negative, let me see what you get. You actually get negative 3.32. So I'm looking at negative 3.32. So that's this top one. I'm less than negative 3. So f of x equals 0. Plugging it into that one. So it's got to end up being 0, right? All right, our last one, we're going to take a look and write an equation for the piecewise defined function whose graph is this one. So let's look at this one first on the left there. So if I look at that, I'm going to start, let me plot some points for a minute. And notice this is a straight line, right? It's a straight line, so it's a line. So it's going to be in this form, mx plus b, right? We got to come up with the equation for that. And notice this first point right here is negative 1, 3, but it's not including it, so this is open. But I do have, let's see these other points. I do have a solid integer coordinates right here, negative 3, 0, right? So it looks like this one, and I'm going to include using that. I know it doesn't hit it, but I can use it because I know it's an integer coordinate. Well, if I got 2 points on this line, can I come up with it? Sure. Name it x1, y1. Name it x2, y2. Find the slope. Number 1, find the slope. So you got 0 minus 3 over negative 3 minus the negative 1, x2 minus, or y2 minus y1 over x2 minus x1. So I get negative 3 over negative 3 plus 1 is a negative 2. So this slope is 3 halves. In other words, it goes up 3, right 2. Can you see it? Or down 3, left 2. Same thing. Negative 3 over negative 2 is also positive 3 halves. Okay, so that's the equation of this line. I'm sorry, that's the slope. That's the slope. Now let's come up with the equation. We know the slope is 3 halves. We already have a point. I could use either of those points as my x1, y1. So y minus y1 equals mx minus x1. So y minus the 3 equals m 3 halves x minus the negative 1. So I got y minus 3 equals 3 halves x times 3 halves times a positive 1 is a positive 3 halves. I add 3 to both sides. In other words, I'm adding 6 over 2. I got to get a common denominator. So I have 3 halves x plus 9 halves. Okay, so far my equation is 3 halves x plus 9 halves. Whenever x is, let's go back up here, less than, notice right here, that's the point negative 1, 3. When I'm less than that, because I'm open right here, I'm less than negative 1. When I'm less than negative 1. So we've done the green line. I have y equals 3 halves x plus 9 halves whenever x is less than negative 1. All right, let me kind of erase this and let's do the other one here. Again, this is what we have so far. Let me erase the rest of this. All right, let's do this other one. How about in red? This is closed and it's going to the right. So that's an x value of negative 1. and I'm greater than or equal to that negative 1. And then this is just that solid line, right? It's just a horizontal line. So what's the equation of that horizontal line? Well, let's look at a few of those points. I have the point negative 1, negative 1. It's closed. There's negative 1, negative 1. I also have 0, negative 1. I also have 1, negative 1. I have 2, negative 1, and so on. Notice all these y values. Y is always negative 1. Y is always negative 1. Y equals negative 1 whenever x is greater than or equal to negative 1. Now this is another way to come up with that is it has a horizontal, it's a horizontal line, so the slope is 0. So you just got to take one of these points. Let's take 0, negative 1, or negative 1, negative 1, either one. And you can write it with point slope form if you know that that slope is 0. So y minus negative 1 equals 0, x minus 0. Well, 0 times anything is 0 over here. So I got y plus 1 equals 0. Subtract 1 on both sides, and you got y equals negative 1. Y equals negative 1. So there it is, the whole thing. A piecewise defined function. Appreciate you guys watching. We'll see you next time.